Today we're going to review a reserve project that we did along the Texas Gulf Coast. We're going to look at how we did the reserves and kind of look back at how the well turned out and how were the results. All right, so the project area is the Texas Gulf Coast. The well is circled in red here. And we did this evaluation in 2013. And to be more specific, the location of the project is about 95 miles from Houston in Calhoun County. So we're in Calhoun County. Here's the well in red. It's called the Appling North Field, Calhoun County, and it's operated by Petroleum Production Company, who is the client for the project. All right, so I met with the client on March 13th, and they gave me they want a report. They want a reserve report as of April 1st. It's always important to get the as of date. And they gave me some information about the Appling field. So they told me about the well, a producing PDP case they wanted me to evaluate. They gave me some information about it. But they also gave me some information about a nearby offset well that's going to be helpful. And they also talked about, what the operating expenses were, because I was going to do a cash flow analysis on it. And they did talk about a flow and tubing pressures that the geologist looked at. So anyway, so they gave me data. I took notes. These are my notes. All right, so let's zoom into the project area. So the subject well is right here, the State Track 209 number 1. It's a directional well. It's operated by Quorum. It's the subject well we're going to be working on. But we also want to talk about the Davis State Track number 1, which is an offset well. That's germane to the project, but it was drilled in '79, much earlier than our well, which is in 2011. All right, so we got a written instruction from the client talking about what they wanted me to do. They did go into some detail about the Frio sand and the fault blocks, but they also did mention that the reservoir size is somewhat difficult from volumetrics, so decline models may be more useful. So you got to always listen to the client. All right, so they did give me this geologic map. Now this is an odd map because it's somewhat like a structure map, but really doesn't have any structure. But it has 2 accumulations, one in red and one in blue. The one in red has been produced by the offset Davis well. But the blue fault block is the subject well that we're trying to evaluate. And they told me that the northern fault block is 187 acres and the southern fault block is 191 acres. So there's similar fault blocks, similar wells, but it's really not a structure map. It doesn't tell you the thickness, or it doesn't give you anything about thickness or water contacts or what the other wells, how thick the other wells in the area are. So it's just kind of a reservoir map. All right, so here's the subject well. It was producing in the 7,400 Frio sand. That's what we're going to be evaluating. So we got a production rate versus time plot here. And we had about 12 months of data for the monthly production, and then we had test data from out the well out a little bit further. So we had production through 2012 with test data out to about March of 2013. And we got flow and tubing pressure here, gas and oil. So that's the data we had on the producing well. So it really doesn't have an established decline on there, does it? All right, so here's the log on the subject well. It's Quorum Production Company. You got to keep those straight. And it was producing from the 7,400 Frio sand. That's the subject reservoir. And we estimate about 6 feet of net pay. We have to estimate that from the log. This is a TBD log. Like I said, we did have some information on their well and all the daily test data, which would be the flow and pressure and rates. But other things you can get from the log header, you can get the density of the mud that they use to drill the well. That helps you when you're trying to estimate reservoir pressure. And you have some temperature data. So sometimes you have to estimate a lot of the reservoir properties if you're going to do, engineering and volumetrics. So you use the log header sometimes is helpful for that. All right, so here's the log header for the nearby Davis Oil Company well that's to the north. And again, there's some mud weight data when they drilled the well, so that can be used to help estimate reservoir pressure. They also had some temperature data from the log and in the bottom log interval. So that all helps you when you're doing reservoir properties. All right. Here's the well to the north. It has a complicated history. Is the production data and the logs showing the subject reservoirs. All right, so it is the well to the north. So it's not the subject well. All right, it started producing gas. This is a gas versus time plot in the 7550 Frio sand down here at the bottom in 1979. But in 1994, they added perfs in the upper zone, 7400 Frio, which is our subject reservoir. But they didn't isolate the lower perfs. So now we have a commingled completion. So now you don't really know how much gas is coming out of each zone. But you can, for the first zone, you can go ahead and project what it would have done if it hadn't have been recompleted to the other zone. So we're going to use this information. So when we look at that, it looks like that lower zone would have produced about 911 million cubic feet. So we're going to use that information to help us when we do our analysis. All right, so that's the data we had. So how can we calculate the reserves for the Coram well, which is producing the 7400 Frio sand? So we could try to look at volumetrics. We do have the map and we have the log data, but the map is not that complete. We don't have, how thick the reservoir is over the area. We just have, 1-2 logs. We don't really know if there's a water contact down dip or, what the other wells in the area did. So we could try volumetrics, but it's going to be uncertain. We could try decline analysis. The well has been producing for 1 year, but it really doesn't have a decline trend, so that's going to be hard. We could try POV analysis, material balance, but we don't have any bottom hole pressures, and we don't have any shut-in pressures. If you have shut-in pressures, you can estimate the bottom hole pressure, but we only have one shut-in pressure on the offset well to the north when it was originally completed, so we don't have enough data to do POV analysis. So can we use other methods? The geologist said he looked at a flow and tubing pressure trend. And, could we use analogy to other fields or, is there anything else? So maybe one of these methods we could try. So let's go ahead and look at the first method. All right, so here's my notes on the 7400 Frio sand and a little tracing of the reservoir map that they gave us. And the subject well is here in red. And the offset Davis well is circled in black. And we have all the notes. And we know the area that the upper fault block and the area of the southern fault block. Okay, so the first thing you got to do is you need to check the scale and areas on the map to make sure the geologist didn't mess up, because if you're going to do volumetrics on these maps, you got to make sure you have the right acreage. So we did that. So what we're going to do is we're going to look at the volumetrics of the deeper sand, the 7550 that was produced by the Davis well, because we have actual results on that well, before they commingled the perfs. And we're going to assume for our analysis that this reservoir map of the 7400 Frio would be the same. The 7550 would have the same shape and size because they're really similar, and they should have same recovery and reservoir performance. So it's a good assumption. So we're going to analyze the deeper zone for this. But to analyze volumetrics, we have to know the average net pay. We got to estimate the bottom hole pressure, gas gravity, recovery factor, formation volume factor. So there's a lot of stuff we got to assume. And but if we go ahead and make the assumptions, do the calculations, the volumetrics of the block to the north for the deeper sand would indicate about 950 mmCF that would be fit in that upper fault block. But remember, when we did the decline analysis on the lower zone, we got 911. So that's similar, but a little lower MCF per acre foot. And then we did check the acreage, on the map. So the reservoir map, the decline analysis and the volumetrics kind of agree. But if we take the actual performance of the well, and we assume that the recovery in this fault block is 975 MCF per acre foot. So we can use that to calculate the reserves for the southern fault block. All right, so the southern fault block, and we're going to use, and for the 7400 Frio volumetrics is the southern fault block, and it is where the subject well is. Okay, so here's our notes on how we did the volumetrics for the southern fault block for the subject well. So we had the 191 acres. We had the 6 feet. We're going to assume that the 6 feet from the log is average over the whole area. And we did have the 975 MCF per acre foot recovery. That was like the best estimate for the northern fault block. So if we multiply the area times thickness times the recovery factor, we get a 1117 MCF of reserves or EUR for the southern fault block. So that would be a volumetric analysis of the southern fault block using the information that we derived from the well to the north. But if you look at the bottom there is a little note that some other trends indicate more potential. So let's look at the other data. All right, so the other data is right here. It's a flow and tubing pressure semi-log plot versus cum gas production of the subject well in the subject reservoir. All right, so we had the flow and pressure each day that the client gave us, and so we knew the flow and pressure versus cum, and we made this plot. We went ahead and did a projection curve fit through there, and we extrapolated down to about 200 pounds flow and pressure, and that would indicate that the reservoir has a potential of 1700 mmCF right here. But remember, the volumetrics said 1117, so it's much shorter, much lower. So which one are we going to use? That volumetrics, that's kind of sketchy. You had to make a lot of assumptions about the thickness and all that. But here we got some performance data. So I'm going to say that probably the best estimate for the reserves of this well would be along this trend, 1700 MCF EUR. So that's what we're going to use for the gas reserves. All right, so what about the condensate reserves? So we know the estimated ultimate recovery is 1700. We know the cumulative at the time of the study in the cum, oil, and gas, and we know what the yield was to date. And then we estimated the remaining yield and the remaining condensate. We kind of assumed the remaining yield would go down a little bit. That's typical. So that lets us estimate that the condensate should be about 19,000 barrels ultimate. So now we have reserves in gas and oil for the well, or ultimate. All right, so here's our graph of the well. So rate versus time, oil, gas, and yield, and flow and tubing pressure. See, flow and tubing pressure is dropping pretty fast. All right, so this is the subject reservoir, 7400 Frio. And we had the monthly production data through the end of 2012 and the test data through March of 13. That's what we had to do a decline analysis. So how did we come up with that red decline here? All right, so what the well was producing, but it really didn't have an established decline. But we know that the flow and tubing pressure analysis said 1700 mmCF ultimate, so we just fit a decline to give us 1700. Here's 1700 at the bottom. And then we just projected the oil to get the 19,000 barrels ultimate. So okay, so this is our reserve projection for the well in 2013 using the analysis we just presented. And so that's the 2013 reserves for the well. All right, so what happened now? We have the history from the well. We got 7 more years of history. So we added that onto the graph. And so the actual results show the well has performed better than I projected. So we went and did a current decline analysis using this line here, and we're going to call that the 2020 estimates. And that gives us an EUR of 2176 mmCF and 16.2 MBO EUR. So the well did better than expected. All right, so what are the conclusions? The flow and tubing analysis was selected for the EUR because of the uncertainty in the volumetric data. Volumetrics was too uncertain. So the EUR, we turned out to be 1,719,000 barrels, but the actual from the 2020 analysis is 2176 gas and 16.2 oil. So the yield on the oil, the condensate yield, was lower than expected. It dropped off much faster than we projected. All right, so then what were the reserves? The reserves are what's remaining in 2013, not the EUR. So the reserves was 1375 gas and 14.9 oil. But the 2020 evaluation of the 2013 reserves with the new data gave us a higher reserve of 1851 on the gas, but a little bit lower on the oil reserves because the condensate yield dropped off faster than we were projecting. So we underpredicted the gas reserves by 35%. Even though we took the higher method that we had looked at, we took the higher method, we were still too low. All reserves we were a little high because the yield didn't follow what we thought. So anyway, that's kind of how we did the reserves. I hope it's a real life example of how you do things with the data that's available. But it's always good to go back and look and see how you did. And I hope this was informative, and just call me if you have any questions. Thanks.